My dear friends, welcome to Rajshekhar classes on Applied Data Science with Python. This is lecture number 401. In this lecture, we will try to understand feature standardization. So, unlike other techniques like logistic regression, support vector missions, k-nearest neighborhood, in all these cases, in all these algorithms, we need feature standardization. First, we will try to understand what is feature standardization. For those of you forgotten it, basically, what is my data set? Let me assume this is my data set. For example, this is your xi. Let me say this is my xi, isn't it? This is my xi, and this is your feature j, fj. This is your feature j. Then what is this point? This point is xij. You are basically converting feature standardization means you are basically converting your xij. This xij will be converted into xij dash, where xij dash equal to xij minus mu j by sigma j, isn't it? Where mu j and sigma j are mean and standard deviation of the column of the feature fj. Yes, isn't it? What is this mu j and what is this? This is, I can say, this is feature j for this particular column. This one is mean, this one is standard deviation, isn't it? This would, what is the benefit of feature? Just try to recall what we discussed about feature standardization. This would avoid impact. This would avoid impact of different features in different scales, I will repeat. This would avoid impact of different features in different scales. But in the case of decision trees, we are not computing the distances. In the case of decision tree, we are not computing distances. That point is important. In the case of decision trees, we are not computing the distances. We are not computing distances anywhere. This is, I can say like this, decision trees, this is not a distance based method. We are not using the distance anywhere. It is not a distance based method. On the other hand, all we care about, suppose if I have a real valued feature, let's call that feature fj. This let me say this is my real valued feature fj, isn't it? This is a real valued feature fj. Imagine if this is my data set and this is my feature fj, then we are building decision tree. What we do, we actually sort this column, isn't it? We sort this column, and when we sort it, we would check for each of these values as, let me say otherwise. Yes, just compare this one. Let me say this one is my feature j. I am sorting all these values. Each of these values, you have values for this particular feature. For each of these values as a potential threshold. This can be a threshold, this can be a threshold, this can be a threshold, this can be a threshold. That's what we discussed in our previous lecture, isn't it? When I am considering feature j, imagine I am at some point here. Just see, I am some point here. This is my feature j. E is threshold, potential threshold. Some point. This is some point in tree. Here I want to do test fj less than e. Let me check fj is less than e. This threshold is what is this threshold? Every possible value fj takes. All these possible values. This can be a threshold. This can be a threshold. This can be a threshold. Let me say this is my e. Let me say I am here somewhere here. This is my threshold value. Since any of these values, this value or this value, any of these values means values of this feature j could be a threshold. All these values could be threshold. That's what we discussed in our previous lecture. Isn't? Remember, it only depends on the order. If all these points, this always depends on the order. If all these points, if all these points, just see, this is threshold value. If all these points, this is E. If all these points is less than E, these points will come left side. If all these points will go to the right side, isn't it? Why? Because E is threshold. Those points which is less than E will go to the left hand side. Those points which are greater than E will go to the right side. In decision tree, we do not care about the actual values themselves, and hence we do not need to do feature standardization. We don't have to do feature standardization. That's important. We don't. Just see, that's what I'm saying here. What it says, just see, all these values which are less than E will go this side. All those values which are greater than E will go to, this is, I'm assuming this is threshold value. Isn't it? That's what I'm saying. In decision trees, we don't care about actual values themselves, and hence we do not need to do feature standardization. We do not need to do feature standardization. We don't have to do feature standardization, unlike other techniques. The simple reason here, we don't care in scale which they are. We only care about something is less than or greater than, unlike other cases, logistic regression, support vector, missions, k, nearest neighborhood, etc., where we care about distances. Distances can be impacted if two features Fy and Fj are in two different scales. So standardization is where we are trying to do, we are trying to get everything to the same scale. We do not have to care about it all in decision trees. This is again one of the important aspects of decision trees, that you don't have to do, any feature standardization. I am repeating, you need not to do any feature standardization. No feature standardization, no feature normalization, nothing. The raw values that you have can use it as it is, because in decision trees all we care about is less than or greater than or equal to, especially if you have real valued features or numerical features. Whereas in the techniques, in the algorithms like logistic regression, support vector missions, in k nearest neighborhood algorithms, we need standardization, isn't it? Basically they are distance based methods. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.